it's problem 4-49. It just wants us to solve for x, and it gives us this triangle. And so we're supposed to remember from Integrated 2 class or geometry that if you have two triangles that are similar, the corresponding parts of the triangles are similar. So I do have two similar triangles. I have the big triangle, and I have the little triangle inside. And I'll just explain why I can say they're similar. This big triangle, it's got 47 here and 23, and this little triangle's got 18 and x. And the reason I'm saying they're similar is because they both share this angle right here. So this angle and this angle are the same because they're sharing it. And so that makes this angle also have to be the same. So these triangles have angle, angle, angle similarity. That means we can write a proportion for them, because that's one of the main things that you learn in geometry or Integrated 2 about triangle similarities, is that the corresponding sides are proportional. So a proportion would be like a fraction. And so I could say, like, this left-hand side right here, I'm going to call that the short leg, because it's got a short leg and a long leg and a hypotenuse. And this one also has a short leg and a long leg and a hypotenuse. So I'm going to say the leg of the big triangle is to the hypotenuse of the big triangle, as the leg of the little triangle is to the hypotenuse of the little triangle. So I can fill the numbers in now, because I know the leg of the big triangle is 23, and I know the hypotenuse is 47, and the little triangle, I know the leg is 18, and the hypotenuse is x. So then I can just solve for x. I like to use cross products when I have these fractions like this. So I'm going to say 47 times 18 is equal to x times 23, or in other words, 23x equals 47 times 18. And then I can get out my calculator, find out what 47 times 18 is. 846 divided by 23. I got about 36.78-ish. And those are units. I don't know if it says how many units they are, but that's the length of x right there. And so the next one, they give well, you can think of this as two triangles, right? You have the little triangle and the big triangle. So here's the little triangle, and then the little triangle is inside the big triangle, right? So on the little triangle, we have, I think that's supposed to be 20. Yeah. On the little triangle, we have 20 on the right-hand side, and we have 35 across the bottom. And then on the big triangle, we have x on the right-hand side, and we have 55 across the bottom. And why am I saying that these two triangles are similar? Well, it's because they're telling me, these little arrows tell me that we have parallel lines right here. And you may or may not remember this from Integrated 2 class, but if you have parallel lines and they're cut by a transversal, then these angles here are called corresponding angles, and they're going to be equal. And same thing's going to happen over here. So we've got angle, angle, angle again. So I'm going to write angle, 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 similarity. So since they're similar, I can just write a proportion. Okay, so I'm just going to go left-hand side is to bottom, as left-hand side is to bottom. I'm just being careful to make sure that I'm comparing the corresponding sides. And then we just do cross products. So 35 times x equals 20 times 55. But what is 20 times 55? Sorry, you can't see. X is about 31.43 units, or that's the length of it. That's it.